Okay, determine the force in each member of the truss and state whether it's in tension or compression. So, looks like another method of joints question. Slightly more complicated than the ones we've done before. Got a few more members this time, and some unknown values. So, the first one I can spot that's unknown is this dimension here, this y dimension of this truss. So let's start by figuring out what this length is of y, and we can do that using arctan. Sorry, tan. So tan of 30 equals the opposite, which is y in this case, over the adjacent, which is 6 meters. So y will then equal to 6 tan 30. And if you put that in your calculator, you should get 3.46 meters. Okay, that's good. We've got that one out of the way. I think we have everything else that we'll need to solve for this truss. So let's now, I don't want to start with joint E because it's got a whole heap of members and applied forces. We might find our support reactions and then solve our way up the truss instead. Okay, so got a pin here, so like that, that. Let's say this is AX, and let's say this is AY, and a roller, so that's going to be just CY there. Okay, so let's take the moment around A and see if we can resolve for CY. I've chosen joint A because we can negate this 600 kilonewton force because it's acting on the joint. So we're just going to have this 450 as well as CY. That's going to create a moment about A. Okay, so let's do some of the moments about A. Define counterclockwise as positive, equals 0. So we have 450 kilonewtons times by the perpendicular distance, 3.46 meters. And this is going to want to turn clockwise. So that's negative. Plus, we've got CY, and its perpendicular distance is 6 meters. Okay, and that's going to want to turn anti-clockwise, so that's a positive moment. So then we have CY. CY is going to be, what's CY going to be, guys? Got that as 260 kilonewtons. Okay, so we've solved CY. Let's put that in, 260. So now let's just do some of the forces in the X. Sorry, let's do some of the forces in the Y first. Because we just got CY and all we need is AY. So we've got CY, which is going up, so that's 260. We've got 600 going down. And I'm going to assume AY is going up, like I've drawn it. 0. So I have AY equaling 340 kilonewtons. Okay. And finally, let's do some of the forces in the X. So we have negative AX, as I've drawn it, and positive 450. AX, 450. Easy. So let's put in AY and AX values. So 340 and 450. What was it? Sorry, AX was 450, wasn't it? Okay, so we've got our support reactions. Now we can strategically pick which joints we're going to do and in what order. So I think starting off with joint A would be the easiest, followed by C, followed by D. We may not even need to resolve E because we might be able to get all the members from A, C, D, and B, summing the forces on those joints. We should be able to get all of the members. So let's give it a go. Let's start with joint A. Joint A, so that will look something like this. So we know the 340 kilonewtons going up and the 450, our support reactions. So this would be, that's joint A, this would be a member AE, and this would be member AB, right? So if we sum the forces in the X, we have AB. Let's assume that that's positive, because I believe 450 was negative, wasn't it? 450 kilonewtons, yeah, that was negative. Okay, so AB equals 450 kilonewtons. And that's acting away from joint A, isn't it? So we know that's going to be in tension. Sum of the forces in the Y equals 0, so we have 340 going up. I'm going to assume AE is going down. Process of elimination. And we have AE equals 340 kilonewtons. Compression. Okay, because it's acting into joint A. All right, terrific. So we've just calculated AB and AE. Let's cross them off. So we've just calculated this one and AE, this one. So we could look at B, but I think there's a few members in there. We might be easier with just going with joint C. So that's got the CY, and we'll need to calculate the CB and CD members. So joint C, looking something like this. So that was 260, our CY reaction force, and that was a normal force, so it's going up like that. This was 30 degrees, and this was CB and CD. Okay, so let's do some of the forces in the Y. So positive 260. And if that's going up, we can assume that CD is going like that, in the negative direction. So CD will be the hypotenuse of our triangle, and we want that Y component. So it's going to be sine 30. Okay, so CD will equal to 260 divided by sine 30, which comes to 520 kilonewtons. And that's, again, acting towards the member at C. So that's compression. Forces in the X. So which X components do we have, guys? Well, we're going to have the X component of CD as well as the CB member, aren't we? So we can assume the CD is going, the X component of CD is moving in the positive, the right X direction. So that's going to be 520. This time the cosine of 30, because we want the X component. And we can go negative CB, process of elimination, equals 0. So CB gives us 450 kilonewtons. And that is going to be in tension because it's moving away from the joint at C. All right, so CD and CB we've just calculated. CD and CB. Now let's take a look at D. joint D. How is this going to look? Well, just going to look like that, isn't it? And we have our 520 that we've just calculated, this 520 here, and that was acting in compression, so it's always going to act in compression, joint D. Then we have, this is DE, and this will be DB. Okay, so sum of the forces in the X equals 0, negative 520 plus DE equals 0, so DE, process of elimination, 520 kilonewtons, also in compression. Some of the forces in the Y. This is interesting. Which Y members do we have, guys? Well, it's only going to be dB equals 0. There's no other forces in the Y, potential forces in the Y direction. So dB is going to be a 0 force member. Okay. Okay, so DE and dB, that's done. DE and dB. So all we have left is this member at dB. Sorry, DE. Sorry, BE. And we have, if we do the free body diagram of B, we should be able to solve for DE. Sorry, BE. Let's draw the diagram so we don't confuse ourselves. Joint B. So we have it going like that. We also have this 0 force member that we just calculated. So look, I'm not gonna show that in the diagram because it's really just going to confuse us. Joint B, and we have, what did we calculate before, guys? So that we have BE is the one that we want. We need to know this angle here. So remember, I'm looking at joint B. So we have the values of members BA and BC, and those were both in tension and both in the X component. So like that, 450, 450. Let's see if we can determine the angle of phi first. We don't have that angle. Phi is just going to equal to arctan of the opposite. What's the opposite? This is the angle that we're calculating. The opposite is going to be 3.46, and the adjacent is just going to be 3 meters. That gives me an angle of 49.07 degrees. Honestly, I don't know whether this is going to help us, because if we do the sum of the forces in the Y, we have, and say we assume this to be positive, like that, we have BE sine, because we're wanting to know the Y component, because we're resolving the forces in the Y direction, sine of 49.07 equals 0, because there's no other Y component forces in this free body diagram. So BE is going to equal to 0 divided by sine 49.07, isn't it? That's just going to be 0. Another 0 force member. Okay. And that's our truss. That's that one done. So we had 2 0 force members this time, 0 force member and 0 force member. But we managed to get all of the other members without even looking at joint E. I think if we had looked at joint E before we did the other joints, we may have had to use simultaneous equations. But luckily we were able to avoid that, and this turned out to be a much easier truss to solve. Thanks for watching.